This video is Unit 1, Lesson 2 continued. Sorry if I was too long-winded in the first one. I'll make this one as brief as possible. This particular set of problems asks you to use the segment addition postulate to solve for the unknown length. Segment addition postulate is basically saying that a part of a segment plus a part of the segment equals the whole segment. Part plus a part is a whole. Add up the segments so you get the whole segment. I don't think there's a ton of crazy things that can happen here. I think the biggest issue with segment addition postulate is students start assuming midpoint. You just did midpoint, so you set things equal. These aren't equal. If you notice, it says find, what is that called without the thing on top? It's pronounced length of AC. So I want you to find me the length of AC. B is not in the middle. There aren't hash marks. There's no discussion of midpoint here. It's telling you the length from A to B is 10. The length from B to C is 13. So the length of the whole line, add them up, 23. The second one says if AC equals 32, the length of A all the way down to C is 32. And if I know that the length from A to B is 25, then the length from B to C must be 7. The bottom two, and this is where algebra is going to come in handy. Just like the previous two, it's telling you a particular length from A to C, the entire length, but now it's an expression, 5x. Same idea. Even though it looks like B is in the middle, you can't assume that it's a midpoint. If the intention of this problem was for B to be in the middle, then I'd have to mark it with those little hash marks, or I'd have to say, hey, B's in the middle. If you notice, there's no speak of that here. Doesn't say midpoint anywhere. There's no tick marks. So we just have to go with what we've got. They gave us part of the line segment. They gave us the other part of the line segment. And then they gave us the entire whole length of the segment. So I'm going to take part of it. I'm going to add it to the other part, and it's going to give me the entire length. So that 3x plus 2 part added to that 18 part is going to equal the entire piece, which is 5x. All right, a little bit of algebra needed. Notice, we have a 2 and an 18 on the same side of the equals. They're going to get combined. 20. I want to get the 3x over here with this friend that's the 5x. Because it's positive, I'm going to do the opposite. Those cancel. So x equals 10. Make sure with the problem, does it just say ask for x? Nope, it's not asking us to find the value of x, it's asking us to find the value from A to B. A to B is this length right here. So that's what it wants from me. We found that x was 10. So I'm going to replace this x with the 10. 3 times 10 plus 2 is going to give me 32. Second one says if AC is 25, find x. Let me get all this stuff out of the way here. Again, you can't assume that B is in the center. It sure looks like it, but you can't call that half and half and say, well, I don't know, I'm going to take a guess that it's in the middle, because it's not. If it was in the middle, it would be specified in some way, shape, or form. Here it says 25 is in the middle. But what I did give you was the length of a part of the segment. I gave you the length of the other part of the segment, and I gave you the value of the entire length. So a part plus a part is going to equal the whole. So one of those parts is 2x minus 6, plus the other part is x plus 7, and it's going to equal the entire value, which is 25. Again, notice that on the same side of the equals, we have some common terms. 2x and a 1x, a negative 6 and a positive 7 equals 25. Double check your problem. Did it just say find the value of x, or does it want a particular length? This problem says find the value of x, so we are done. Hopefully that one wasn't too painful, just an extra 5 minutes. Let me know if you have any questions in class. Email them to me, whatever works. Thank you so much.